All right, this is a screencast for experimental design practice A, basically how to do an experimental design diagram. First off, when you're doing an EDD, which it will look like this, experimental design diagram, also known for short as an EDD, you'll have a bunch of boxes that you need to fill out, and you will not necessarily start at the top. In fact, you don't. The very first thing, and I've put numbers off to the side to help you here, the very first thing you're going to do is the independent variable, or the IV. Now, if you come to a definition or a word that you're not sure of, what you'll need to do is check your experimental design vocabulary, which is page 1 of your notebook, and you will be able to find different definitions like independent variable. It's the factor or variable that is purposely changed by the experimenter. It's the factor the experimenter decides to change. So if we head back to our EDD, that means we have to decide what we're going to put in here. Well, what I need for you to do now is to read this scenario. You should have the worksheet at home, but if you don't, you can read off of the screen. Go ahead and hit pause on the video. Read the 2 paragraphs, and then we'll return to finishing up the assignment. Okay, so you should have read the scenario, and when you read about Tom and Nate, the very first thing you're going to be asked to answer is the IV. And the IV, in this case, what Tom and Nate decided to change was the amount of salt that's dissolved in the water. So that's the first thing you'll do. The second thing that you need to do is the dependent variable. And the dependent variable is the data that you collect in an experiment. It's the thing that you're counting or measuring, the thing that you're worried about at the end. And when you think about what Tom and Nate counted or measured in this experiment, they counted and measured the number of drops. Of water on the penny. All right. Now that moves us to number 3, which is the levels of the IV. We'll change over to the draw tool. Now, when it comes to this particular part, you have to break the independent variable into the different groups that we have. And in this case, we have several different levels of the IV. Since it's the amount of salt, if you go back and look in here, you can see that one beaker had no salt, another beaker had 0.5 grams, 1 gram, and 2 grams. So that means there are 4 different levels of the IV. The very first one is 0 grams. Then we have the 0.5 gram, the 1.0 gram, and the 2.0 gram. So these are all, notice, amounts of salt that were put into the water and how many levels of those were there. Now that leads you to 4, where you need to do a control. If you go back to your vocabulary, there's 3 ways you can have a control. 1, it's where the IV is omitted, the level suggested by an outside standard, or in the case of comparisons, the one the experimenter picks. When we go back to our IV, we can see that it has been omitted here. Salt has been omitted. So that one, it would fall under that definition, the first one, and so that would be our control. Repeated trials. Tom and Nate, notice it said that they repeated their test 5 times with each beaker. So you're going to come in and you're going to put that in each time. So you realize they repeated this test 5 times with 0 grams, 5 times with 0.5 grams. So that's why each one is going to have 5. That moves us up to our title. And when we go back to our definitions, there is a template for how to do the title. It's always going to be the effect of, and then you put in the changes in the independent variable on the, and then you plug in the dependent variable. This is the reason why we did the independent, the IV and the DV first, so that we could do that. So when we come into this particular part, we always start off with the effect of. So the effect of the IV, which is the amount of salt, on the DV. And in this case, the DV, you just go down to your dependent variable, is the number of drops of water on a penny. So the effect of the amount of salt on the number of drops that fit on a penny. All right, that moves us to the hypothesis. The hypothesis, if you come to it, it has a template as well. If the independent variable is how the IV is changed, then the dependent variable will describe the predicted effect. So we're going to fill in these blanks as we do this particular statement. Now, notice I will always say that a hypothesis has to be an if-then statement. So no more I think statements, but if-then instead. So we return to this. So if I come in here and I do my hypothesis, it has to be the if-then statement. So if the amount of salt is, let's say, increased, then the number of drops of water that fit on a penny will, I'm going to say, decrease. And I gave it a direction there. Now, it doesn't matter if you said that this is going to increase. It may. It's your best guess, your educated guess on how it's going to affect it. And notice it's if IV, then DV. So if the amount of salt is increased, then the number of drops of water that fit on a penny will decrease. And then that leaves us with our constants. Constants are nice. You always need 3, and they're the things that remain the same in an experiment, thus the term constant. So what other things are going to remain the same? Well, if you go back and read about Tom and Nate, notice that it has several things that they talked about. They talked about that Nate made all the water drops. They used the same penny. They always used they did it on a dry piece of paper towel. So we can go in and we can fill those in. They used the same penny. They used the same person made the drops. They were from the drops dropped from the same height. There's 3. You could do more. They use the same dropper, or we'll call it a pipette, which is the thing that you use to drop the water on there, etc. And once you have 3 of those, that will work. That's how you do an EDD.